Welcome back. We're going to be going over FRQ number 4 in our Unit 6 review packet. I'll have that packet linked in the video description. And of course, I'm going over chapters 8 and 9 in the Practice of Statistics textbook, updated 6th edition. So all the references you see on the pages will be from that textbook. Read through the question. In order to monitor the populations of birds on a particular species of 2 islands, the following procedure was implemented. Researchers captured an initial sample of 200 species on Island A. They attached leg bands to each of the birds and then released the birds. Similarly, a sample of 250 birds of the same species on Island B was captured, banded, and released. Sufficient time was allowed for the birds to return to their normal routine and location. Subsequent samples of birds of the species of interest were then taken from each island. The number of birds captured and the number of birds with leg bands were recorded. The results are summarized in the following table. And you're given this here, what they're providing us are on Island A, the number of captured birds, 180, and the number of leg bands in the subsequent sample. Island B, the same thing. Assume that both the initial sample and the subsequent samples that were taken on each island can be regarded as random samples from the population of birds of the species. The question, did the data from the subsequent samples indicate that there is a difference in proportions of the banded birds on these 2 islands? You have statistical evidence to support your answer. So you, of course, aren't going to be given this little hint, but how do you know it's a 2-sample test for P1 minus P2? Well, what we're going to do is we're looking for, do the data indicate there is a difference in proportions? So do we have evidence? That's a test. We're not trying to estimate with 95% confidence. We're trying to provide evidence. So we are going to do a test. And because we have 2 samples, it's going to be a 2-sample test for z-test for P1 minus P2. So look at the hints if you need to. Pause the video and try it on your own. Okay, guys, so we're just going to check our work here. This is a 2-sample z-test for P1 minus P2. I set my hypotheses up like this. I say, ho and ha, do P1 equals P2 since the word is difference. So that's a not equal to. So my HA would be P1 is not equal to P2. Now I do want to define my proportions. So P1 is the true proportion of banded birds on Island A, and P2 is the true proportion of banded birds on Island B. And since I was not given one, I'm once again going to use a 0.05 as my alpha level. Now, just be careful on this problem because up here, there was an initial sample of 200 for Island A and 250. And while those were the initial sample, that's not the sample we're using because they didn't all come back. You know, hopefully nothing bad happened to them. Maybe they just left, flew away. But this is what we're working with. So if you look at just these 2 numbers, the number captured for both of these is what our sample is going to be. So this would be like N1 and this would be like N2 in that case. Okay, so just be careful. This would be your X1 and X2. If you're looking calculator speak, that's what we're looking for. So we're not going to use those 2 numbers because they didn't all come back. Interesting because, yeah, so we're just missing a few left over. So anyway, once you've done that and defined your parameters, let's go on to our conditions. We want to do our random samples taken. It's stated in the problem, so we have to state that here. We can assume that our 2 sample sizes, 180 and 220 from our returned birds, are both less than 10% of both islands. That's the best I can say. I don't have any other information to say otherwise. And when we're talking about our large counts, we want to use PC. Now, if you don't remember what that is, go to your formula sheet. And here's a formula for it. It's the number of successes for both divided by the total in your sample sizes, added together and divided. So you can see here, if I do the 12 plus 35 over the 180 plus 220, that's going to give me about 0.1175. Now I want to go right into here and, you know, once I've checked all these are greater than or equal to 10, I'm not going to get bogged down with formulas, especially with this one, because you're not really required to show this formula when you're doing the calculation as long as you need the test. So I'm just naming the test like I did at the beginning of the problem. And I'm going to go right into here. This is a two-prop z-test. When you're going to your stat menu, you're going to go to stat tests, and you're going to do a two-proportion z-test. You want to input your counts. So x1 is going to be 12 over 180. x2 is 35 over n2 220. And we do want to use not equal since this was a not equal in our HA. And I'm going to go to calculate first so I can get all these values. And you'll get your z-score of negative 2.856. Write that down and also write down your p-value. Those are the two important things you need for the do part. You can also calculate the p-hat1, p-hat2, and the p-hat, which is your PC. So this really is p-hat from your calculator. And you can verify, you can run the test prior to doing your conditions if you want to get that, 0.1175, but that is the number we do use for your conditions. Obviously, our p-value is pretty small. So in this case here, we are going to reject our null. We have convincing evidence that these two proportions of banded birds are different. And remember that this is a two-sided test. So what happens is if I were to run this and do the draw feature, it's going to shade the left part here and the right part. So while you're given a negative 2.856, you can barely see it, but there's a little bit shaded under here and under there. That's actually doubled from a one-sided test. You do not double that. It's already been doubled for you. So that is your p-value. And that would be good enough here to get full credit on this. You don't have to show work for that part. Thanks for watching.